Okay, so this is number 6 from your review, okay, from page 356. And what this one's going to ask us to do is they actually evaluate for what the exponent would be to make this statement true. So 2 to the what would have to give me 16, basically, or 3 to the what would give me 81, and so on and so on, okay? So that's what logarithms and exponentials, that's their relationship, right? So what we could do this one of two ways. I might bounce back and forth for maybe A and B on how we could do this the two ways. So method 1, let's say while doing question A, would be to switch this thing into an exponential, right? So switch to exponential. Okay, the work's very similar in the sense that like you're trying to figure out what the exponent needs to be to make a statement true. But what's going to happen here is I'm going to say for A, for me to switch this thing into exponential, you can see that the base of the logarithm is 2, so the base doesn't change. So the base of the exponential is also going to be 2. All right, so we're going to get 2 to what exponent? So 2 to the exponent, which would have been over here in exponential form. So 2 to the x is going to equal 16. This is the question you're asking yourself, right? And so we say, okay, well, what exponent would give me 16 with a base of 2? So you could do that, or you could say, I'm just going to apply some of the exponential work that I would have used in grade 11, where I make the bases match, and then you say, well, 2 to the what gives me 16, right? So 2 times 2, so 2 squared would be 4, 2 cubed would be 8, and 2 4 would give me 16. And so what we can say, once the bases match, you could say, okay, well, we're going to drop the 2's now that the bases match, okay, and you're going to get x is equal to 4. Okay, so for number 2, for B, what I can also do is leave it in logarithmic form, okay, and ask yourself, okay, well, how could I rewrite 81? Very similar in the sense that, like, I'm trying to rewrite 81 with a base of 3 so that when I have log base 3 to the 3 to something is going to equal x, right? And that something is what I'm trying to figure out, and ultimately what x is going to equal, right? If I were to be bouncing back and forth. So we learned because like something like 3 to the x, the graph of 3 to x would be something like this, right? Just generally. And we learned within this unit that the logarithm of a base 3 is actually just going to be the inverse of that. So this is a very rough sketch, but the inverse of that is going to be kind of something that's been reflected in that line of y equals x. So it's going to be something like this, right? So the idea there is that this is log base 3 of x, right? And they're inverses of one another. So anytime I can make these bases match, then I can actually just drop them out because they're inverses. And so 3 to the 4, so if I could rewrite this as the thing that goes on the 3 there is going to be a 4, right? And so the logarithm drops with the base of the exponential, and you just basically get x is equal to 4. Okay? Now, C is starting to get a little more interesting because we've got kind of a fraction going on there, right? So I'm going to rewrite log base 4. Maybe I'll flip-flop. I'll do this. I'll express this one as exponential. Okay, and so what I'm going to do is I'm going to say 4 to the x is equal to 1 over 16. And I can make 4 to the x is equal to 16 to the negative 1. And then 4 to the x, the game here, the game is to get a 4 on this right side. So 4 to the something is going to give me 16. Well, that something is going to be 2. And then this has to be multiplied against the negative 1. When I do that, we can drop the bases out. We're going to be left with x is equal to negative 2. Okay, and for question D says, let me just copy down again, log base. Now here's the catch. They didn't write a base on here, so we know the base to be 10 if they don't write one, of 0.00, how many zeros? 3, 4, 5, and a 1, okay, is going to equal x, okay? So again, same thing, I'm just going to write this as 10 to the x has to equal 0.000001, okay, which is essentially 1, 2, 3, 4, 5, 6. Okay, so we're going to see that if, this is just almost saying scientific notation, right? How many times do I have to basically divide by 10? You're going to divide by 10 6 times, right? So you're going to get 10 to the negative 6 is going to equal 0.00001. That's not enough zeros, I don't think. Okay, and so x is just going to equal negative 6. Okay, and that's it.